Hi class. For this section on other measurements of the center, you're basically looking at the following. So all of these actual formulas are going to show up in the rest of the sections starting at 3.1. So I treat it as a separate section, but in reality, it's all just evaluations that they're going to want you to do. Now, you're still talking about the same idea, and that is that, well, you may be talking about a sample or a population. And you just have to be very careful in terms of what they're asking. If it says mean and they don't attach anything else as a regular mean, so any one of these two, depending on if it's a population or a sample. Now, we have technically other types of mean. And all of these are really messy, so you would only be asked to evaluate these on very small data sets. Yet again, the n% trim mean tends to be a large data set, but I wouldn't give you anything very, very large. No longer the 15 values. Typically, we're looking about 10 for any major examination. So this is all I need for any of the, well, in this case, different means that we're doing. I need you to tell me which formula you're using, punch in a couple of values, and then run it in the calculator so you wouldn't have a lot of values to evaluate. I do need to see the formula, and then you're using the proper variable mu if it happens to be a population and x bar if it's a sample. Then you're evaluating each of those. Okay, let's take a look at example 1. In an example 1, they want us to evaluate on the very first one the mean. And in this case, this is a sample, so I'm just going to talk about this one being x bar, and this is the sum of the x's divided by n. Now, what you could do here is technically, so let me exit that, enter the data set. So let's go to the data set. And enter it. So I have it as dataset number 2. I have 4, 5, 7, 9, 12, and the values of 10. Okay, so for this one, just write me a one variable stats. But make sure you're running the actual value of A2, of L2, sorry. And 7.83, they want 4 decimal places. So I'm just gonna write it as either approximate or equals 7.833. So this is approximately 7.8. So 833. We're running to 4 decimal places. So let me just double check that there is, yeah, there's always 3 afterwards. So that would be our actual final answer. And all I need you to tell me is that you're technically using the one variable stats, so you can just put it on the side. And then in this case, you're letting me know that you're actually using the shortcuts of the calculator. So I still need to see the variable, the formula associated with each of these, and then your final answer. Now, let's take a look at a different type of mean. This is the quadratic mean. Now, your quadratic mean, and let me go to this one. It's actually given by the following formula. It gives you the sum of the x squares divided by n. So this one, there's unfortunately no shortcuts. So we would have said that this is the actual equal to the sum So this is the sum of the x squares divided by n. And on the good news, you do have this as a shortcut only for a piece. So the sum of the x squares is 415. So this is 415 divided by how many values you have? You have 6 values. So please evaluate that, and then we'll compare values in a minute. So 415 divided by the values of 6. Let me fix my 6. And I'm looking at 69 0.1667. Please evaluate that and see if you're matching. Once again, it's 415 divided by the values of 6. And I'm obtaining the 415 from the one variable stats. It's basically that. That's the sum of your x squares for that specific one. Let's take a look at the geometric mean. Now, the geometric mean, it's basically defined as follows. You're going to take the nth root of the multiplication of all the values. So this particular one is going to be tricky to evaluate. In this case, our geometric mean is going to be, and you're looking at a total of technically 6 values. So this one will be the actual 6th root of the multiplication of each of these. So you're looking at technically 4 times 5 times 7. So this will be 4 times 5 times 7 times 9 times 12 times 9 times 12 times 10. Now, your calculator may not understand the actual 6th root, so in your calculator, you're basically going to do the following multiplication. So this is going to be 4 times 5 times 7 times 9 times 12 times 10, and then you're going to raise it to the 1 divided by 6. That is the proper code that you would be running. Let me walk you through it because this one's a little bit tricky. So we're going to actually put parentheses, and then you're going to say 4 times 5 times 7 times 9 times 12 times 12 times 10, and then technically raised to the 1 divided by 6. Please evaluate that and see if you're matching. You have to be very careful. Make sure that the exponent is evaluated properly. And I just confirmed it with my other calculator. So this is 7.29, 29 because of that, 2989. So that would be to 4. So 7 point, you can write it as equals or approximately equals. I'm getting 7.2989. So that would be rounding to a total of technically 4 decimal places. Let's take a look at the harmonic mean, and you have to be very careful for the harmonic mean. The formula says that you're dividing technically n by the sum of every reciprocal. So this was going to be a little bit hard to evaluate in the calculator, but this is how you're going to punch it in so that I know that you're evaluating this one. So in this case, your actual harmonic mean is going to be equal to, so you just have the values of 6 on the top over, and then for these messy ones, it's sufficient if you just tell me what you're doing at the bottom. So in this case, you're going to be doing 1 divided by 4 plus 1 divided by 5 plus 1 divided by 7 plus 1 divided by 9 plus 1 divided by 12 plus 1 divided by 10. And you have to be very careful on this one because of the parentheses or the position of the parentheses. So let me actually run this one. And you're going to say 6 divided by, open parentheses, 1 divided by 4 plus 1 divided by 5 plus 1 divided by 7 plus 1 divided by 9 plus 1 divided by 12. Whoops, error right there. So that would be a 12 plus 1 divided by technically 10. Close the parentheses and hit enter. I'm getting that this is approximately, this is 6.76 21. So 6.70, oops. So 6.70, whoops, yeah, no, 76, 21. And the 1 is just a surrounding. So that happens to be our main answer. Let me just double check that one to make sure that we don't have any typos. Sorry, I was just double checking that our answer is correct. In this case, we're actually matching. So I'm getting 6.76, technically 21. That would be for the harmonic mean. Now, I still want to see the formula, so it's perfectly fine on these messy ones that you're telling me what you're typing in into the calculator. So I want to see at minimum that, or that you're obtaining this from the actual, well, part of the one variable stats. If you go back to the calculator, very easy to make a mistake like on the previous one. If we by accident not closed it properly, let me just retrieve that answer. Like if we had not closed it properly, the answer might have actually not been able to calculate. And I'm talking about, if you look at this one, that specific parentheses there. So if you don't actually open and close the parentheses, it may not calculate it.